Good morning, everyone. Before we get into the meat of today's training, let me first introduce myself. My name is Mariusz Jarosz, and I have the honor of working at Danfoss for over 10 years as a technical support engineer. My work is mainly focused on refrigeration and air conditioning, and my office is located here in Poland in the application and technical support department. As a part of my duties, I provide comprehensive technical support to our partners through whom Danfoss distributes its product. I also work with OEM clients and installers. My role is to provide professional technical support and solve any questions or problems you may encounter in connection with our products and solutions. Today, we are pleased to gather here for a 2-hour training session that will focus primarily on issues related to Danfoss condensing unit, but that's not all. This is what today's training plan looks like. I will start by discussing the Optyma Plus Series Units for use with standard refrigerant as well as with class 2 A2L refrigerants, example with a very low GWP coefficient refrigerants. I will discuss the range of products and their features and benefits. In the next part, I will discuss the iCO2 4.6 kilowatt unit for application with the natural CO2 refrigerants. I will discuss the technical specifications of this unit and what to pay attention to when bidding. The next issue is the iCO2 Optyma Control Cold Room controller. Here I would like to present the basic advantages of this controller. For example, easy installation and parameterization, and emphasize its communication capabilities with other Danfoss systems. And finally, I would like to present a thermostatic expansion valve for CO2 installation, what performance range can be handled, and what applications can be used for. This slide, we present the outdoor Optyma series multi-refrigerant condensing unit range. On the left, you can see the first two condensing units that belong to the Optyma Slim Pack series. They are especially attractive if price a key factor for your investments. They are available in two variants, WO5 and WO9. The WO5 version offers basic equipment, while the WO9 version additionally includes a main switch and a fan speed controller. Both versions feature a macro-channel condenser and high-quality compressor, which transfer into high efficiency and quiet operation of the units. The next unit, third from the left, is a premium device, Optyma Plus. It has a completely soundproof housing and full automation, such as controller, pressure transducers, temperature sensor, and displays. Thanks to this, you can achieve a very high efficiency and precisely regulate its operation. It is also possible to connect the unit to the monitoring system, and the installation and commissioning process is much simpler and safer. Optyma Plus units are available in two versions, POO and PO2. The PO2 version is a low temperature unit and equipped with a controller and an electronic valve for liquid injection, which enables operation at a very low evaporation temperatures. Finally, you can see the Optyma Plus inverter unit, also from a premium segment. This device features valuable capacity thanks to the use of frequency converter. This means the highest efficiency and lowest operation cost of this unit, precise temperature control, and simple and quick installation. Further, we will focus only on the condensing units marked with a red square. On this slide, we present a summary containing key information about the capacity ranges of Optyma Plus condensing units and Optyma Plus inverter units, depending on the refrigerant used. Analyzing this data is extremely important because it helps understand the cooling capacity of individual condensing unit family. The list shows that the Optyma Plus inverter units are only available in a medium temperature version, and there are no versions available working with ultra low GWP refrigerants such as R454C or R455A. In addition, we note that the Optyma Plus family of units has a wider cooling capacity range. We have already mentioned the microchannel exchanger, and now we would like to focus on the benefits of its use in condensing units. The first important benefit is a much higher cooling coefficient of performance, COP. This is because the microchannel exchanger has a higher thermal efficiency than the traditional fin and tube exchanger. Thanks to this, with the same size of the exchanger as a traditional one, it is significantly oversized, which results in a lower condensing temperature. Another key aspect is the much smaller internal volume of the microchannel exchanger compared to the fin and tube one. Thanks to this system, with this type of unit can use up to 35% less refrigerant, which is important in the face of rising refrigerant costs on the market. Additionally, the design of microchannel heat exchanger is completely different than traditional finned tube heat exchangers, which makes them much more durable and lighter. This is in turn affects the weight of the entire condensing unit. Let's also not forget about the unique compressors used in our condensing units. This slide mentions the MLZ and LLZ series compressors. These are scroll compressors that are exceptionally reliable. Therefore, just like microchannel condensers, they are a key element of condensing units, significantly influencing their advantages. We move on to the part of the presentation devoted to Optyma Plus family condensing units. Let us now discuss the advantages of the Optyma Plus family condensing units. Extremely quiet. The units are designed to minimize noise. The interior of the compressor chamber has been soundproofed, and selected compressors are equipped with acoustic hood covers. Additionally, a silent fan with a variable speed is used, which transfer into quiet operation. Energy efficiency. The units are not only quiet but also energy efficient. Thanks to them, you can achieve up to 20% higher COP efficiency compared to similar products available on the market. Solidity and reliability. The units are enclosed in a waterproof housing, which guarantees their solidity and reliability in various operation conditions. Plug and play. Optyma Plus is a plug and play solution, which means that installation and commissioning are extremely simple and convenient. Stackable installation of the units. The units are also designed to mount one unit on the top of the other unit, which gives more flexibility in installation. Continuing our presentation, let's discuss further advantages of the Optyma Plus premium segment condensing units. Micro-channel heat exchanger. Our units are equipped with a micro-channel heat exchanger, which means less refrigerants filling and easy of keeping this element clean. Advanced electronic controller. And electronic controller located inside the unit provides instant information on pressure, temperature, and other parameters. This allows for quick response and diagnosis of possible problems. Triple doors. Our units feature triple doors for easy access during startup and servicing. Moving on, discuss the advantages of Optyma Plus units. Let's pay attention to the photo on the right, which shows how much space we can save by mounting several units on top of each other. Stackable installation. The units can be installed in a small area. This method of installation also ensures an aesthetic appearance, which is important for both functionality and aesthetics. On this slide, we will look at the features and advantages of using an electronic controller in the Optyma Plus family unit. In the left part, we see a diagram of the individual elements of the units that are connected to the electronic controller, which acts as the brain for the entire unit. There are temperature sensors and a section pressure transducers, a liquid injection valve, a compressor, crankcase, heater, a discharge temperature sensor, a discharge pressure transducer, a condenser, fan, an ambient temperature sensor, and an alarm output and input switching on the unit. Features of the electronic controller: superheat, pressure and temperature monitoring, condenser and compressor fan speed control, crankcase heater performance control, day and night operation schedule ensuring maximum condenser and compressor fan speed, possibility of remote alarming, external display setting module, and possibility to connect to the ADAPT Cool system manager via Modbus. Advantages of electronic controller: faster and easier installation. There is no need to connect additional sensors and measuring instruments. Reduce the risk of errors during installation. Energy saving. Additional temperature input. Moving on to discuss the controller of the Optyma Plus condensing unit, I would like to draw your attention to the way in which the controller regulates the condensing temperature depending on the ambient temperature. By entering the appropriate setting in the controller, you can precisely determine how much higher the condensing temperature you want to achieve depending on the ambient temperature. The lower the outside temperature, the lower the condensing temperature we can achieve. It is worth noting that by reducing the condensing temperature by just 1 degree, you can achieve 2 to 3% energy savings. This clearly shows how important a role of controller plays in increasing the efficiency of the entire unit. Another interesting function is the ability to increase the condensing temperature during night operation. This allows us to ensure that the condenser fan runs at a lower speed at night, reducing noise levels. The controller has a real-time clock that automatically changes the operating mode to night and day. At night, the condensing temperature set point is increased by a certain amount, which allows the unit to operate more quietly. These controller functions are crucial for the efficiency and comfort of the unit operation. Another useful function of the Optyma Plus unit controller, which affects its efficiency, is controlling the compressor crankcase heater. The controller has a built-in thermostat that supervises the operation of the compressor crankcase heater. The function is active when the compressor is stopped. The control is based on monitoring the ambient temperature and the temperature of the section gas. The heater's capacity is controlled by the controller itself, calculating the required power and delivering it in the form of pulses. This functionality allows for effective energy measurement and maintaining appropriate operating conditions for the unit, which translate into savings and reliability. In this slide, we will focus on possibilities offered by Optyma Plus unit in the iCO2 version. The left side shows the installation diagram of the unit, showing various elements of the fittings, regulation and security system. The iCO2 version of the unit is equipped with the electronic expansion valve that enables precise liquid injection into the compressor, which helps to reduce the discharge temperature. On the right side of the slide, there is a part of the electrical diagram where we highlight an additional module that allows for the regulation of liquid injection. This module also monitors the discharge temperature, monitors the phase sequence, and checks the presence of voltage. These functions are crucial for the efficiency and safety of Optyma Plus unit in the PO2 version. Continuing the discussion of the Optyma Plus unit in the PO2 version, I would now like to present the operating range of the unit for the R449A refrigerant, which is characterized by a high discharge temperature. On the slide, you can see the operating envelope of the unit, which shows the evaporation temperature range, which is from -40 to -10 degrees Celsius. This wide spectrum of evaporating temperatures makes the unit versatile and useful in a variety of applications. We move to the next Optyma Plus inverter unit. Here you will also find many interesting innovative functionalities. The Optyma inverter is an exciting extension of Optyma Plus family, which offer a wide capacity range across 4 different housing types. The Optyma inverter unit is available only in one housing, namely the H3 housing, which is the largest in the single fan version. In the right photo, you can see that these units look like. You will notice a slightly different logo here and the ability to see the compressor and frequency inverter. Additionally, it is worth noting that the walls of the unit are soundproofed from the inside with foam, which affects its acoustic performance. As you can see, the Optyma inverter unit can also be referred to as the Optyma Plus version P01 unit. It is a versatile unit that can be called special purpose because one unit is able to precisely adapt to load changes, making it suitable for a variety of applications. Example, in the food industry, in ice machines, in bakeries, etc. Stepless capacity regulation from 30 to 100 RPS transfers into 20 to 30% lower energy consumption compared to fixed capacity condensing units. Commissioning the unit is easy despite advanced functions. The initial parameters in the controller are already pre-configured, which shortens the commissioning process and ensures safe operation. The unit contains proven and properly selected components such as Danfoss compressor and inverter, which guarantees reliability and efficiency of operation. Installing the unit is very simple and is based on the plug-and-play principle, which means that the installation process is safe, simple, and hassle-free. Full and advanced control is provided by the Optyma Plus controller, which offers functions such as alarm management, day and night operating modes, and the ability to communicate with the ADAPT Cool System Manager, which we talked about when discussing the Optyma Plus in the POO version. Condensing units equipped with inverters provide more flexibility in selection than fixed-speed units. Selecting the right inverter condensing unit can be done using the following methods. Select a condensing unit size that achieves the desired peak load cooling capacity at a maximum speed. Attention! It is necessary to ensure that the minimum capacity of the condensing unit at a minimum speed, 30 revolutions per second, does not exceed the required cooling capacity of the smallest evaporator. If the minimum capacity at 30 revolutions per second is higher than the required capacity of the smallest evaporator, then the condensing unit may operate outside its operation envelope, which may consequently shorten the service life. The heart of the Optyma inverter unit is an advanced Danfoss scroll compressor combined with the intelligent inverter. This synergy is based on the intelligent CDS drive logic and the special VLZ compressor, which was developed significantly for refrigeration applications and equipped with a patented IDV technology. What is extremely beneficial about this cooperation is the fact that you do not need to make any changes in the inverter settings. The inverter works as a slave, and all configurations are made via Optyma controller. The controller also serves to protect the condensing unit by implementing various safety functions such as increasing the quality of compressor bearings lubrication at a low compressor speeds, protection of the unit when the discharge temperature reaches too high level, adjusting the compressor speed in response to a low load at a simultaneous high ambient temperature, limiting the compressor speed in night mode. Optyma inverter is a truly impressive refrigeration unit that is characterized by extremely high efficiency. As you can see in the left chart, in the SEPR efficiency index for some units can be as high as 4.1. Now let's consider what contributes to such impressive efficiency of this unit and what energy saving benefits can be achieved thanks to it. There are four key features that contribute to this outstanding efficiency, and some of them are truly unique and not wealthy. Permanent magnet motor. This is one of the main factors. A motor using permanent magnets is more efficient and durable, which translates into lower energy consumption. Inverter modulation. The Optyma inverter condensing unit uses inverter modulation, which means it can adjust its capacity depending on the current needs, which is a significant factor in energy saving. IDV, indirect discharge valves. This is a solution that affects the efficiency of the compressor, which in turn transfer into the efficiency of the entire unit. Microchannel condenser. We speak about this. This type of condenser has significantly higher thermal efficiency compared to traditional solutions, which allows for even better results in energy savings. In this part of the training, we have something special for you. We would like to present you new state-of-the-art condensing units from the Optyma family. These are not ordinary units. They are designed to work with the natural refrigerant CO2, carbon dioxide. Today, we will look at the model Optyma iCO2 4.6 kilowatt for medium temperature applications. Ready for the fascinating world of modern condensing units? Here we go! More and more CO2 is coming in refrigeration, not only to big centralized systems, but also to condensing units. That's why in Danfoss portfolio appear iCO2 4.6 kilowatt condensing unit. Danfoss has quite a condensing unit product range. These are bare units and packaged units for using outside. On the slide, you can see packaged units, different types with different equipment, with fixed speed or variable speed compressors. Danfoss has in the offer both units for refrigerants class A1 like R449A, but also multi-refrigerants units to use with A1 and A2L refrigerants. Here, this unit from the right side is iCO2 4.6 kilowatts for using with CO2. On this slide, we present a refrigeration system, more specifically a typical single-stage system with a gas bypass valve, which is able to operate both in transcritical mode, when we have a high external temperature, and in critical mode, when the ambient temperature is low, resulting in the condensing temperature below the critical point. The components of the system include a gas cooler, a liquid receiver, a high pressure valve, a gas bypass valve for pressure regulation, a compressor, and a fan. On the left side of the slide, there's a log pH diagram on which appropriate points corresponding to the states of the system, such as compression, gas cooling, or expansion, are marked. This is an important tool for analyzing the operation of the refrigerant system and its efficiency in various conditions. We begin by discussing the features and advantages of the Optyma iCO2 4.6 kilowatt condensing unit. Now let's move on the details that distinguish this unit from other solutions. Now we will focus on the technical characteristics of the unit. In the image, you can see what the device looks like, and next to it, there is an infographic with information about its equipment. This unit is equipped with scroll compressor with adjustable capacity ranging from 30 to 100%. It is also possible to connect it to the system manager. The unit includes a gas bypass valve and a microchannel condenser. It is equipped with display, a relief valve, an integrated inverter for the compressor, and a controller. Additionally, it has two liquid receivers with a capacity of 2.5 liters each. The fan speed is adjustable and there is a 2.5-liter section accumulator on the inlet. Importantly, it is possible to stack the units on top of each other, which may be useful in some installations. This slide shows the capacity of this unit for both maximum and minimum operating speeds. We note that there is a limitation on the maximum operating speed, which occurs when the outside temperature is above 38 degrees Celsius. This results in a significant reduction in the capacity of the unit in the event of very high external temperatures. This is important information to consider when designing and installing the cooling system. Now, let's take a closer look at the operation envelope. On this slide, we present the operating envelope of the iCO2 condensing units 4.6 kilowatt. We note that the evaporation temperature range is from -20 to 10 degrees Celsius. The maximum ambient temperature at which the unit can operate is +46 degrees Celsius, with the rotation speed limited to a maximum of 93 revolutions per second. This is important information that helps you understand under what conditions this unit can operate effectively and allows you to properly adapt it to a specific application. Now we will move on to further details related to the functionality of this unit. Here we provide an overview of the features and benefits of using Optyma iCO2 4.6 kW compared to variable speed HFO refrigerant solutions. Customizable monitoring and management. These units offer multiple connectivity options such as MMILDS master and CAN bus gateway, enabling scalable system monitoring and management solutions. High energy efficiency. With a wide range of capacity adjustments, brushless fan and compressor technology, this unit stands out as a best in the class in terms of seasonal energy efficiency. Solidity and reliability of years. Thanks to the use of the highest quality components, this unit ensures reliability and efficiency even in extreme conditions, where the ambient temperature can reach up to +46 degrees Celsius. Quiet operation. Thanks to the use of the best-in-class BLDC compressor, excellent acoustic insulation, and an efficient, quiet fan, this unit is characterized by a low noise level. The noise level does not exceed 35 decibels and at a distance of 10 meters, which is almost twice as low as in case of standard condensing unit. Choosing the Optyma iCO2 4.6 kilowatt unit is a reasonable and effective solution, combining advanced technology with energy savings and operational reliability. On this slide, we present various possibilities of communication between the unit and the refrigeration system. Standalone operation of the unit without communication with the cooler. In this configuration, the unit operates independently. It controls operation based on internal parameters such as temperature and pressure. Features include pump down mode, internal controller, and local display. The unit operates in response to the thermostatic operation. The unit can be optimized to work with thermostats in cold room controllers. When the thermostat detects the need for cooling, it will send a signal to the condensing unit to turn on. In addition, the unit can transmit alarm information via a relay in the gateway, which allows for ongoing monitoring of the system status. Connecting to the condensing unit to other evaporator controllers and the master units via Modbus network. This advanced configuration allows the condensing unit to communicate with other evaporator controllers and the master units via Modbus network. This makes it possible to manage the system comprehensively, including both thermostatic regulation and pump down regulation. Thanks to various communication options, you can adapt the operation of the unit to the specific needs and requirements of the refrigeration system. Now we move on the part of the presentation in which we will look at the arrangement and functions of individual elements in the iCO2 4.6 kilowatt condensing unit. Let's start by talking about the technical specifications. As you can see, the unit stands out for its low noise, emitting just 35 decibels. It weighed approximately 116 kilograms and give possibility to put one unit on the top another. Equipped with external main switch and easy to open doors. This is a single-phase unit operating at 230 volts. Below we can see both minimum and maximum capacity at minus 10 degrees Celsius evaporation and 32 degrees Celsius ambient temperature. The connection size is a standard 3/8 inches. This slide shows a drawing that highlights the main electrical components of the condensing unit and their location in the unit. The filters and the central controller, which is integrated with the inverter, are located above the fan. On the opposite side, we can see electrical box, external main switch, and gateway. There is a display on the front of the unit that allows you to adjust and change setting just like in other Danfoss controllers. Now let's take a closer look at the other elements. On this slide, we can see how the rest of the elements are arranged in condensing unit. Physically, looking in real at the unit, most of these components are insulated and packed together, making them difficult to see. That's why such drawings are extremely helpful. On the left, we see the diaphragm, and on the right, we see physical arrangements of the components. In the diagram and in reality, we notice elements such as the MCHE microchannel exchanger, bypass and high pressure valves, safety valve, compressor, liquid receiver, filters, and bow valves. These drawings are also included in the unit documentation, where pressure transducers, temperature sensor, and other important components are described in details. Thanks to this information, installer can better understand and operate the condensing unit, which translates into efficiency and reliability of the operation. Now we will move on the part of the training when we will explore the topic of unit control, Optyma iCO2 control loop. The unit is managed by four main independent control loops. Compressor speed regulated by section pressure. The compressor adjusts its performance to the section pressure level. If the pressure drops, the speed drops. If pressure increases, the speed increases. Additionally, there are fixed values of turning the compressor off and on. High pressure valve regulates the pressure on the gas cooler depending on the temperature at its outlet. The valve adjusts the pressure on the gas cooler depending on the outlet temperature. In transcritical mode, above 25 degrees Celsius temperature outside, the high pressure valve optimizes the COP, cares about energy efficiency. In subcritical mode, below 25 degrees Celsius outside, the valve maintains a pressure of 35 bar above the section pressure. This is related to the compressor operating envelope. The bypass valve and the pressure in the liquid receiver are controlled by the temperature in the liquid receiver. This loop controls the pressure in the liquid receiver. In case of high outdoor temperature, transcritical operation, the gas relief valve maintains the pressure difference between receiver and section at plus 30 bar. The gas bypass valve is closed when the valve when we have low outside temperatures. Fan speed is controlled by the gas cooler outlet temperature, especially in extreme high and low temperatures. In addition to these four main loops, we must not forget about the fifth one, evaporator control. Here we control the temperature in the refrigerated area, but also regulate the appropriate superheat. The comprehensive control system ensures optimal performance and efficiency of our unit. So on this slide, I see it's a repetition of the gas cooler control loop. High pressure valve controls gas cooler pressure depending on the temperature at its outlet. In transcritical operation above 25 degrees Celsius outside, high pressure regulation valve optimize COP. In subcritical operation above 25 degrees Celsius, the valve maintains a pressure of 35 bar above the section pressure. Its relation to operation envelope of the compressor. In addition to the standard control loops, we have implemented emergency safeguards that take over control in the event of extreme conditions. Below, we present the limit values at which these protections come into operation. Regarding protection against excessive pressure in the gas cooler, we see that when the pressure exceeds 112 bar, the high pressure valve gradually increases its opening to reduce the pressure. When the pressure reaches 118 bar, the compressor automatically reduces its speed. If the pressure exceeds 140 bar, the compressor will be completely turned off. Protection against excessive pressure in the liquid receiver works similarly. When the temperature reaches 27 degrees Celsius, the bypass valve opens completely. An increase in temperature to 30 degrees Celsius causes the compressor to slow down. And after exceeding 33 degrees Celsius, the compressor is completely turned off. Another safeguard ensures that the discharge temperature does not exceed permissible values. The discharge temperature of 128 degrees Celsius forces the high pressure valve to open wider. At 132 degrees, the compressor speed is reduced, and when the temperature exceeds 138 degrees Celsius, the compressor is completely turned off. This additional safeguards guarantee safe and reliable operation of the unit even in hard conditions. Now, we will deal with issues related to running the installation. We will discuss what elevation we can take into account and what are the maximum pipeline lengths that can be used in our refrigeration system. What should you pay attention to if we have an installation where the evaporator is mounted at the top and the condensing unit at the bottom? There are some key points worth considering. Elevation up to 5 meters, maximum pipeline length of 20 meters. Both pipeline section and liquid should be properly insulated. It is recommended to use a solenoid valve. It is important to prepare a liquid trap. A step in the pipeline may be necessary to prevent liquid from accumulating at the valve. By taking care of this aspect, we will ensure the proper functioning of our refrigeration installation, even if the evaporator is installed at the top and the condensing unit at the bottom. In this case, we have a different configuration where the condensing unit is located at the top and the evaporator is at the bottom. It is worth paying attention to several important aspects. In such an installation, it's recommended to use an oil trap in the section pipeline every 2.5 meters. Sufficient diameter of the section pipe is necessary to ensure proper flow velocity in the range of 8 to 12 meters per second. Thanks to these solutions, we ensure effective and reliable operation of the installation, even when the unit is placed at the top and the evaporator at the bottom. This slide highlights an important aspect related to the amount of oil required depending on the specific situation. We present two different situations taking into account maximum ambient temperature of 32 and 38 degrees Celsius. There is an noticeable difference in the amount of oil that may be needed depending on the conditions. Here we can see the catalog number for a can of oil, 250 milliliters. However, it's worth noting that amount of oil may change depending on temperature conditions. It is worth using a dedicated Excel sheet that allows of accurate calculations of the maximum refrigerant and oil filling adapted to specific temperature conditions. This allows you precisely determine how much oil is needed in a given situation. In this part, we will discuss an extremely important issue: the amount of refrigerant required for the proper functioning of the system with the iCO2 4.6 kilowatts condensing unit. For a system with an iCO2 condensing unit, it's necessary to calculate the amount of refrigerant required to its proper operation. We can calculate this using an appropriate spreadsheet in Excel. Alternatively, we can estimate the amount of refrigerant using the equations below. The total amount of refrigerant in the system is a sum of amount of refrigerant in the unit, 2.15 kilogram, the amount of the liquid line, and the amount of evaporator. The amount of refrigerant in the liquid line is calculated by multiplying 0.04 kilogram per meter by the length of the liquid line in size 3/8 inch. The amount of refrigerant in the evaporator is calculated by multiplying the density of the refrigerant at a given saturation temperature by the volume of the evaporator. However, please remember that the amount cannot exceed 1.35 kilogram. After summing the amount of refrigerant in the condensing unit, liquid line, and evaporator, we obtain the total amount of refrigerant in the system. On this slide, we present an Excel spreadsheet that is a useful tool for calculating the amount of refrigerant and the amount of oil required in our refrigeration system. It's worth paying attention to the area marked in blue, where we make the appropriate entries. First, we provide the maximum ambient temperature and then complete the information regarding the length of the pipeline, the volume of evaporators, and the evaporation temperature. This sheet will help us calculate the maximum refrigerant charge of the system and the amount of oil that should be added to the system to maintain its efficiency and reliability. We now move on the other important issue regarding the offer of iCO2 4.6 kilowatt condensing units. There are several key aspects we should pay attention to ensure that the condensing unit will operate efficiently and reliably in your system. In this section, we will focus on the key parameters you should check and adjust to ensure optimal performance and reliability of your iCO2 4.6 kilowatt condensing unit under various conditions. Below is a list of those important parameters. Performance and thermal load. The maximum system load must not exceed the maximum capacity of condensing unit at the highest expected outdoor temperature. The minimum thermal load should not be too low compared to the minimum cooling capacity of the condensing unit to avoid frequent switching on and off of the unit. Ambient temperature. The ambient temperature must be taken into account when determining the capacity of the condensing unit, as it may differ from the average values. Evaporator value. Restrictions related to filling the refrigerant. For example, there is no problem with the volume of 10 liters at temperature of -5 degrees Celsius. However, the larger charge may pose a risk of loss of refrigerant under certain operating conditions. Pump down operation should not be used with evaporators with a volume of less than 2 liters to avoid very low section pressure during the final pump down stage and excessive discharge temperature. Piping. Depending on the location of the evaporator, appropriate piping parameter should be taken into account, such as pipeline length, maximum 20 meters. Elevation difference up to 5 meters. Working pressure of the liquid line is 80 bar. Section line and evaporator with PS pressure of 60 bar, preferably 80 bar. Expansion valve. It's recommended to choose the appropriate type of expansion valve depending on the situation. We can choose step valve, pulse width controlled valve, thermostatic expansion valve. Accurate selection of valve has a significant impact on the efficiency of the system. Most similar small units require step motor valve. With CO2 4.6 kilowatt condensing unit, we can operate with AKV valve, as the MOPD is managed by iCO2 controller. Danfoss also offer PV for CO2 that we can see at the drawing. We will speak about it later on. During our meeting today, I would like to share an example of successful installation of 3 Optyma iCO2 units, 4.6 kilowatt in Spain. This particular installation aims to provide effective cooling in the pharmaceutical sector. Now, we will move on the next stage of our training, in which I would like to introduce you to the family of cold room controllers called Optyma Control. Before we go into the details of the Optyma Control family, I would like to emphasize that Danfoss is a leading component manufacturer. Danfoss offers a wide range of components, and if we look at applications such as cold rooms, we will see that Danfoss can supply a variety of products to different areas. In the field of control and monitoring, we have Optyma Control and IoT devices and service applications. When it comes to the low pressure regulation, we offer solenoid valves, electronic and thermostatic expansion valves, and superheat control regulators. We have many components that can be used in refrigeration equipment, such as condensing units, pressure switches, filter dryers, miniature pressure switches, compressors, inverters, condenser, fan speed controllers, side glasses, ball valves, and even microchannel exchangers. Of course, Danfoss also has ready-made condensing units, both outdoor and indoor units. If we dive into world of Optyma control controllers, we will see a family of controllers that we have at least three unique advantages. I will briefly discuss them. These controllers are designed to be easy to install and configure. They can be used both in standalone installation and in systems supervised by central systems. We have a variety of models to suit different application needs. They allow the integration of these controllers with Danfoss system and other communication platforms. Here, I present to you the advantages related to easy of installation and quick commissioning of the system. This process includes mounting the controller, connecting sensor and other system elements, selecting the appropriate application, and finally configuring set point, differential, and defrosting mode. Now, I will discuss how to connect the controller to a specific application. Various applications are implemented in the controller depending on the needs, such as cooling regulation, type of defrosting, or control of cooler fans. By selecting a given application, we can find the electrical diagram assigned to it, which facilitates correct connection. Now, let's move on the commissioning process. Commissioning can be divided into two main steps. The first step is to select the appropriate application that is responsible for cooling regulation, type of defrosting or shutdown with pump down, and control of evaporator fans, depending on the need and configuration. The next step is to select the set point value, confirm it, and then the controller takes control of the condensing unit and the cooler. Thanks to the quick commissioning wizard, we are able to shorten assembly time by 25%, reduce the risk of errors, and ensure easy and efficient commissioning. Another significant advantage of controller family is their ability to communicate. The controller can be integrated both with the ADAPT cool system and via Prosa tools, also directly to the cloud. This slide I just showing you to leave you with the information that this controller can be used in both medium temperature and low temperature applications, both in standalone system like the one on the top and in centralized systems. Here I present the entire family of these controllers. The first one has 4 outputs. The second one has 5 outputs and a current protection. And the third one has 5 outputs and advanced functions enable greater optimization of the system. At the end of the presentation, I would like to present a summary of the specification of the 3 controller models. Thanks to this, you will be able to easily understand the differences between the individual versions. Moving on the last topic of our training, we will discuss thermostatic expansion valves designed for CO2-based systems. On this slide, we present the benefits of using thermostatic expansion valves for CO2-based systems. These valves are intended mainly for small and simple refrigeration systems. The advantages of their use are easy installation and no need for precise adjustment. The use of these valves is ideal for small power pack systems and condensing units with capacity of 5 to 20 kilowatts. Examples of applications are cold rooms and refrigeration cabinets. The maximum working pressure is 90 bar. For applications such as condensing unit, thermostatic expansion valves can be used in transcritical system with a high pressure valve and a gas bypass valve. The maximum differential pressure that can be used is 60 bar. Condensing units designed to work with CO2 are in standard equipped with a variable capacity compressor, which allows one or more evaporators to be connected to the same unit. In such a configuration, it is important to install a solenoid valve in the liquid line, in addition to the thermostatic expansion valve. Then the previously mentioned Optyma controller can be successfully used. Another application in which a thermostatic expansion valve can be used is small and medium-sized centrally supplied systems where the K factor is the investment cost. The product is dedicated to installations such as convenience stores and small supermarkets. It is worth noting that the case of systems with a thermostatic expansion valve, TV, the efficiency will not be as high as in the case of electronic expansion valves, EEV. It is important to understand this difference, especially when choosing the right technology for a given application. And at the end of the presentation, we would like to present the available orifice sizes and the range of capacities that can be handled in medium and low temperature applications. That's all what I wanted to share with you. Thank you for the attention. I hope this material was interesting and valuable for you. I will invite you to watch other movies that will appear on this YouTube channel. And bye for now.